Meyya Meyyappan is a materials scientist who has won many awards, including NASA's Outstanding Leadership Medal. He is currently the director at the Center for Nanotechnology at NASA's Ames Research Center. Today I've come to meet Meyya in Boston at the city's public library to find out how NASA is using nanotechnology in its space exploration program. Thanks for joining me today, Meyya.
You're welcome.
So nanotechnology itself, it's quite a broad term covering a lot of different science. Looking today at NASA's nanotechnology program, what kind of areas does that cover?
The driving need are the theme behind NASA's nanotechnology program. In some funny way, you can think of NASA as the place that runs the world's largest, Weight Watchers program. Okay, the reason I say that is because every kilogram of anything that we lift to the near Earth orbit, it costs us about $25,000 in logistics. The same kilogram, if you have to lift it to Mars and other planets, it costs us $250,000. Okay, so we constantly worry about the weight. Okay, so that's why I call our program is a Weight Watchers program. Okay, so obviously you can't ask the astronauts to lose weight or whatever. Instead, the agency looks to engineers and scientists like me and ask us to reduce the weight of the payload. Okay, so it's a relentless miniaturization. Okay, think of it, whether it is a mass spectrometer or whether it is a fluorescence spectrometer, okay, whatever it is, okay, trying to make them smaller. So the size and the weight, everything is smaller. And equally important is the power consumption, because wherever we go, we don't have a utility company where you can dial in and ask for electricity. We have to generate our own power, whether it is wind or solar. So it's important that our instruments don't consume too much power either.
So it sounds like you're talking about both the space flight and the scientific instruments that are necessary as well. So can you name any specific missions or specific examples where nanotechnology has been used effectively by NASA? So
far we have tried one product in the space exploration program. We have a carbon nanotube-based chemical sensor, which is a gas or a vapor sensor. And it was tested in the International Space Station for air quality monitoring of the crew cabin. So we were monitoring things like formaldehyde. Formaldehyde, the allowed, the limit is 1 part per million over an 8-hour period. Okay, and there is currently no sensor available in the market that can provide that kind of sensitivity. So that's why we developed this nano sensor, and we tested this in the space station, and it worked very well.
So I suppose if you look back to the 50s and 60s and the space race, there were some technologies that emerged from that, which then trickled down into society and different areas of science at large as well. Are there any examples of nanotechnology breakthroughs that have then trickled into other areas of science?
For example, this carbon nanotube-based gas vapor sensor that I mentioned, that is one technology that will be very valuable, to the society. In fact, we have made an effort to integrate that sensor into a smartphone, okay, for air quality monitoring. And it will also be useful for biomedical applications because the medical community is increasingly coming up with biomarkers in the human breath.
So, going back to the space race example for a moment, when NASA was established, it's kind of developed this culture where it's very project-driven. There's clear objectives, like get a man on the moon. I was wondering, is there ever a tension between that approach and the approach of science, where it's often more curiosity-driven, where you're never quite sure what's going to emerge from the research? Is there ever frustration there for you as a scientist.
It is beginning to happen. When we started about 15 or 16 years ago, at that time, my management at NASA Ames, they realized that nanoscience and nanotechnology has just got started, and it was going to be quite a while before we can actually produce a widget that we can hold in our hand. And so in the first several years, I would say even the first 5 or 7 years, it was mostly curiosity driven and a lot of basic research. But things have changed for a couple of reasons. One is we cannot, as a government lab, we cannot continue to work as a curiosity driven basic science type thing, essentially competing with the universities. You know, we have to stand apart from universities. So in the last, I would say about 7 or 8 years, we have focused primarily on developing a product.
If you were kind of to allow yourself to speculate for a moment, I mean, looking say 50 years ahead, are there any particular nanotechnology applications that you think could be really exciting in space exploration? Yeah, things that have potential.
Well, the way I look at it is, let's take this, the Curiosity rover that's in Mars right now. The way I look at it is, in about 10 years' time, the next generation rover should be quite a bit smaller, okay? Instead of being the size of a Mini Cooper, probably the size of a smaller, golf cart or whatever, and perhaps a lot lower cost. How do you think that's going to happen? We are talking about miniaturization. You have to, again, I'm going back to my driving theme, increase functionality per unit weight. So only science and technology that is going to help you there is nanoscience and nanotechnology. It's the novel materials, the carbon nanotubes, the nanowires, or graphene, or whatever.